Peter. Hello everybody, lovely to see you all. I am CTO at what's called Health Data Research UK, as Peter was saying, and we have a 20-year vision and mission. So our mission is to accelerate trustworthy data use to enable discoveries that improve people's lives, and a vision for large-scale data to benefit every interaction with patients, every clinical trial, every biomedical discovery, and to transform public health. That sounds brilliant, doesn't it? But what does that actually mean? So what we're really trying to do is accelerate the researcher journey. So all of these little orange dots here represent a stage in that journey. And to bioinformaticians out there who are thoroughly, blissfully ignorant about the challenges of actually accessing health data, I'm here to raise with you some of these challenges today. However, it's also really quite an exciting time. So the way in which we're trying to do this is by improving health and boosting UK science by making it easier to find, access and use high quality data. Provide leadership to fix difficult technical problems, and to accelerate and streamline health data science by developing collaborations that can connect people, data and organisations across this journey. So I would say there's two different worlds here. We've got the world of bioinformatics and we've got the world of health informatics, which looks at clinical data in the fantastic way that Ian was just describing there. I come from the world of bioinformatics. So I have a PhD and a postdoc in bioinformatics. Having had a little stint in industry, I then came back to work in health informatics. And I really see that these worlds are now combining. Now, I'll just give you a quick alert here that there's going to be quite a few little animations in here, just, you know, showing some funky stuff along the way. It's mainly because Janet Thornton hates them. So I thought I'd put in some extra ones just to make sure everybody enjoyed the moving slides as they go through. What we're trying to do here is bring together the world of life sciences data with a partnership with the Elixir and the clinical data. And so you can only answer certain questions by bringing these two things together. But I actually think that health informatics and clinical world can learn an awful lot from the bioinformatics world. So in bioinformatics, it's brilliant. There's this lovely collaboration. Everybody loves everybody. Everybody shares everything. We've got these fantastic reproducible pipelines, or at least we like to think it's all that good. But we're moving towards that in bioinformatics. In health informatics, because the data is about people, it's highly sensitive. And so what generally tends to happen is you've got silos of data where the data is really locked down and challenging to get access to. And so because the data's locked down, the indirect implication of that has meant that the infrastructure and the code and the analysis stuff has also been locked down. Now, it needn't have been, but it is more challenging, and you really have to innovate in terms of how you can share data and how you can share the infrastructure and the code while still maintaining data security. So I'm going to give an idea today about the different steps along this journey that bioinformaticians need to be aware of. So this is a sort of back to basics talk around access to health data, with the plea, I hope, by the end, that actually it's really quite an exciting area to work in. And if we could bring some of these skills of bioinformaticians to this, that would be fantastic. So first of all, we're going to move to a lovely world of finding data. So imagine there's 47,556 different clinical systems out there in hospitals across the UK. I've got no idea how many there are, but they're fragmented and they're really difficult to access. Then you've got all the data that you collect at GP practices. It's actually really quite difficult to say, well, how do I get access to this data? So there's hundreds and hundreds of them. You also have routinely collected data linked to research data too. So when every single data set out there has its own web page for you to go and find and be able to have a look at the different data sets, how do you find which of those million different websites to go to? Well, what we're trying to do within HDR is create a gateway. And this is basically a signposting place to point you at the different websites and the different locations that you can find out there. So you can search for over 1,000 different data sets. We've got a very large number of users, and my battery's going. What you can find there is metadata. So that's data about a data set rather than the actual data itself. And you can find associated publications, associated data analysis scripts and software. And you can also send queries to the different data providers and say, oh, can I get access to your data, please? They say, yes, come back with a form filled out. So if you go to the gateway, you can go to have a quick look at data sets and biosamples. Then you can go and have a quick look at all of the ones that come back. And then you can click on an individual data set and you can see lots of different information about that and go and follow through. The other thing you can do is much more deep analysis. So cohort discovery tool is an idea of being able to query federated data sets in a secure way. So I want to find how many people there are between the age of 20 in the various different data sets across the UK. So for the data sets that have onboarded onto the cohort discovery tool, just send one query from a centralized resource, sends out the query, and you get back aggregate level counts. So completely anonymous information. So this is really useful for finding data that you need, but also for recruitments for clinical trials. So this is an emerging project. We're trying to get population-wide data sets at the moment. So we're working with the SDE network that has all of the TREs across England. And we're also working with Scotland and CPRD for GP data. And it utilises what's known as the OMOP Common Data Model, which is quite widely used in the field of health informatics. So now we're going to go on, and I hope you're watching this, Janet, because it's quite neat. Look, access to data. So now we're going to have a quick look at how you might go and do that. So this is probably quite a challenging slide for everyone. I'm sorry, we're going to have to go into information governance, but this is really, really important for making sure that your data about the fact that you've got to take an ointment 4 piles, your colleague who's looking at health data can't actually see and be able to tell that. So it's really important that we make sure we do this in a safe, transparent way, which supports the public. So sensitive data is data about people, and it can be consented or it can be unconsented. So you can actually work on population-wide data sets, but it can be unconsented in order to access some of that. So under GDPR, though, there has to be a legal reason to process that data for research. So it could be research in the public benefit, or it could be consent that you're using. And we also have to apply the law of confidentiality. So nobody along that process should be able to tell who the data is about. And applications to access data must cover the legal basis for doing these things. So what we're utilising is something called the 5 Safes framework, and this has been around since about 2027, not 2027. 2007. I'm feeling old. This framework makes sure that you look at 5 different variables to make sure that when you're accessing data, you're doing it in a safe way. So the people that are accessing the data have to be safe. And by that, we mean that they have to be fully trained on how you use sensitive data in a way that isn't potentially disclosive. And you have to be able to have appropriate skills to make sure that you're not completely misinterpreting the data and publishing absolute nonsense. The projects have to be safe, so they have to be ethical. You can't just use this sort of data for marketing purposes. Drug companies can't just come along and say, we want to find out the best place that we should target sales. They have to be in a safe setting, and I'm going to go into this in a little bit about how you have to access it in safe environments called trusted research environments or secure data environments. The data has to be safe, which means it has to be de-identified and it has to be almost impossible for you to work out who somebody is. And when we're looking at data leaving these secure environments, we have to have safe outputs, which means you can't take the raw individual level data out of those environments. All you could take out is a graph or a trend which summarizes the information. And you could of one person in a particular cell, because otherwise by its very nature you might be able to work out who that person is through low numbers. So in terms of training, fortunately, different data providers or different data custodians require you to do different courses. but many of them utilise a course run by the Office of National Statistics called the Accredited Researcher course. So if you're interested, you might want to go and have a look there. HDR also run a load of courses on how to analyse health data, and these are all free courses, so please do go and have a look if you're interested. Then on to the next stage, which is data access requests. So many of the different forms that you have to fill in to access a particular data set will ask you questions around the 5 safes. So they're interested in those 5 main things. Unfortunately, many of them ask the same questions, but in slightly different ways and slightly different orders, which can be quite a pain in order for you to work out how to navigate that landscape. So what we've been doing is working across many hundreds of different forms, working across the community of data custodians, and we've come up with a standard set of questions which pretty much cover all the questions that many of them were asking, and we're working on adoption of that set of standards. And in the gateway, we've also set it up so that there's a standardized data access request module. So for data custodians that want to use this, they can accept the information in the same sort of form, and you can have a whole workflow underneath it, etc. So now we're going to go on from access data to linking of data. So the opportunity for linking data is really, really valuable here. So what we're talking about is you might want to find out some information about people in a particular clinical data set from a hospital, but it's an awful lot more complete if you can link that with their GP records. You're going to be able to find out an awful lot more about those people. And even further, if you can link health data to, let's say, education data or finance data, you can ask a lot more questions with being able to do this. But actually, it's really, really challenging to do because of the sensitivity of this data around the place. But if we could do it, it would actually really enable us to do some fantastic things, both in terms of economic benefit, but also policies around how we look after people. So we locked a load of people in a room, said they couldn't leave until they'd answered come up with some really good questions. And we looked at just 10 different use cases where you link data from different sectors. And those 10 different use cases, we then did some economic modeling, and the impact of being able to do that was absolutely, absolutely huge. So DARE UK is really trying to work in that way about linking data across different environments and across different sectors. And interim director of DARE, and what we're trying to do is make it so that it approaches the ease and the pace at which you can access open data, but still have those sorts of controls in place. And we're wanting to develop new technologies and innovate in this area to have the controls, but to still very much streamline it. So I'm now going to go on from linking data onto curating data. So this is a sort of a key slide, really. Unfortunately, to access health data, you have to use something called a trusted research environment or a secure data environment. They're much of a muchness, same term for different things. Within these environments, you log in, you can see your data in place, but you can't install all of the stuff just as you might want to. You don't have free access to the internet. So you have to get all of your stuff in that environment, analyze it, and then when you want to take out your results for publication, you have to put them in an airlock. Somebody comes and looks at that, makes sure that it isn't disclosive, and then you're allowed to take it out. So it does put a security bubble around these sorts of things, and it adheres to the 5 safes principles. So what we're seeing is this world where previously clinical data you used to be able to get from data sharing agreements and signing your life away in blood that you weren't going to do anything dodgy with it, to now only being able to access this data within trusted research environments. And the number of environments out there has dramatically increasing over time. But I would add that this is only still a very small fraction of the research compute environments out there. So we're seeing this change to TREs. It's been really positive in terms of the support from the public about how their data is used, which is great. It's provided this extra level of security, fantastic. However, If we're going to force researchers to use these environments and go through those hoops, they have to be fit for purpose. And this is some of the key research that we're trying to do in terms of our innovation. So these environments are costly to set up and run, less funds for research. Data analysis processes take far too long. If you are interested in using health data, make sure you plan out a year ahead of time in order to actually be able to get it, because it is highly likely it will take about a year to get access to data. There's a lack of interoperability across these environments. They don't meet all the types of research that you might want to do. We're really sort of pushing the boundaries here as to what we can do. But AI, for instance, is a real challenge. And when you've got data in lots of different really locked down silos, it's actually really quite challenging to do federated projects where you're looking for data from different ones. So once you've got access to data and you're in your TRE, the next thing is the quality and the standardization of that data. And that's when you need to be able to have data management platforms. That's when you need to be able to curate and add value to that data. And unfortunately, you still have to do that in the world of health informatics as you do with bioinformatics. This is one such example with the BHF Data Science Center COVID work, which Angela is going to be talking about. This is a dashboard which is developed by the BHF in order to have a look at all of the data and stuff that's available within that environment. So I'm now going to go from curating data onto analysing data, and at this point hand over to Angela, who I've noticed has worn a T-shirt just to match with my red blobs, my orange blobs. There you go.